Question number 5. So the weekly revenue from selling the refurbished iPod Nanos can be modeled by this function shown here. It's a quadratic function given in the vertex form. And based on that, they want to know part A, what is the weekly revenue for selling 50 nanos? So you know that N is the number of refurbished iPod Nanos sold. So N equal to 50. You want to plug into your function. So R of 50 is minus 1.5 times 50 minus 60. So you plug in N equal to 50 into your function here. Squared plus 5700. If you put that into your calculator, it will tell you it's 5550. So that means the weekly revenue from selling 50 refurbished iPod Nanos are $5,550. And don't forget to add your units in this final conclusion here. So that's part A. For part B, find the maximum weekly revenue and how many refurbished iPod Nanos must be sold to make that maximum to happen. So first, if you look at your function, it's a quadratic function and it opens down because this is a minus in front of this squared. So it has a maximum. How to find the maximum? It should be this number added outside the square. So the maximum weekly revenue would be $5,700. Then next, let's calculate when that happens. So in order to get that, we have to set whatever inside the bracket equal to 0. So n minus 60 equal to 0, n is 60. So we know that 60 refurbished iPod Nanos must be sold in order to reach that maximum amount of revenue. So that's part B. Number 6. So very similar question. V is total fresh vegetables consumed, and T is a year since 2000. So V is a function of T. You can see that it's again a quadratic function. So part A, what is V of 6 and its meaning? So we plug in T equal to 6 into your function here. So V of 6 is 0.7 times 6 minus 1.5 squared plus 95.4. And your calculator will tell you this number is 109.575. For part A, it asks you to round your answer to the nearest integer. You look at the next digit to the right, this is 5. So 5 to 9, we know that we all have to add 1 to your number. So 109 plus 1 is 110, or say 110. So that's how you do the rounding. Next, you want to explain its meaning. So that's based on T equal to 6, V equal to 110. So T, if you look at the definition of T is a year since 2000. So basically that's year 2006. And V is 110. What is V? V is the total fresh vegetables consumed per person in pounds. So put that together, that will be in 2006, the total fresh vegetables consumed per person was about 110 pounds. Again, don't forget to add your units here. That's part A. For part B, find when the minimum occurs and what is the minimum amount. So if you look at the quadratic function, it opens up, so it has a minimum. So first we want to know when is the minimum. That means we need to set this bracket equal to 0. So t minus 1.5 is 0, t is 1.5. Then let's look at what is the minimum amount. We know that for the quadratic function given in the vertex form, this number added outside of the bracket squared, that should be your maximum or minimum amount. So in this case, the minimum should be 95.4 pounds. So if we write the final conclusion, that would be the minimum intake of the vegetables was 95.4 pounds, and it occurred when t equal to 1.5. So if you look at t is the year since 2000. So if t equal to 1.5, that means 1.5 years since 2000. What does that mean? That means right in the middle of 2001 and 2002. Should be the midway through 2001. So that's the way t equal to 1.5. Number 7. Suppose the newest version of your favorite smartphone comes out today. So we see a total of 30 people go to the dealer today, and each day the total number of people who purchase this doubles. So from there, each day the number of people doubles. You know that this shows you an exponential model. So first you want to find S of t, where S of t represents number of people who have purchased a smartphone t days since today. So you know that this is an exponential model. So it has the format of a times b to the power of t. And from here you want to know a and b. So do you know b? The answer is yes, because each day the total number of people doubles. So that means your base multiplier is 2. So now we don't know what a is. But we do know some data point, because today we have 30 people. Or say the 0 days since today. So t is 0. S equal to 30. B equal to 2. We can plug in that. So 30 equals a times b to the power of 0. We know b to the power of 2 to the power of 0. And 2 to the power of 0 is just 1. So a is 30. So that's how you calculate your a. Now we know a, we know b, we can plug into the model. So S of t is 30 times 2 to the power of t. That's part A. Then part B, we want to know how many people have purchased the smartphone 7 days from today. So that means t equal to 7. So S of 7 is 30 times 2 to the power of 7. And your calculator will tell you that number is 3,840. So you know that according to the model, 3,840 people have purchased the smartphone 7 days from today. So that's part B. Number 8, very similar question. So we have the flu epidemic broken out in all MATH1215 courses at your school, and a total of 9 people have the flu today, and each day total number of people have the flu triples. So each day number of people triples. That means this is an exponential model with the base multiplier equal to 3. So if f of t here, we can write that as a times b to the power of t, because it's an exponential function. and B is 3, because each day the number of people triples. So, but we don't know A yet. But we do have the data point that today we have 9 people have the flu. So T equal to 0, F equal to 9, and B equal to 3. We can plug in that. So 9 equals to A times 3 to the power of 0. So 3 to the power of 0 is just a 1. So A equal to 9. So now we know our A, our B, so we can plug in the function to get the model. So f of t is just a 9 times 3 to the power of t. That's part A. For B, how many people at your school will have the flu 4 days from today? So t equal to 4. F of 4 equal to 9 times 3 to the power of 4. This is 729 from the calculator. So you know that 729 people will have flu 4 days from today. That's part B.